Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at ellipses that are centered at the origin. So it looks like there's two scenarios here where either the major axis is horizontal or the major axis is vertical, but we can really use the same approach in both cases to graph these. So the number under x squared is either a squared or b squared. If the number underneath x squared is the larger of those two denominators, then it's a squared. And if it's the smaller, then it's b squared. But the same idea applies. We're going to plot a point at the center. And then we're going to take the number that's being squared underneath the x squared term and move left and right by that amount. And then the number underneath the y squared term will move up and down by that amount. And then we'll just connect them. Drawing an oval is a little easier than drawing a circle. The major axis always has length 2a. That's the bigger of the axes going across side to side or up and down. The minor axis is the other one, and that always has a length of 2b. One thing about the definition of an ellipse that's important is that there are 2 points called foci. The singular is focus, but there are 2 foci, F1 and F2. And if we pick a point on the ellipse and we connect it to both of those foci, that distance is the same no matter what point we pick on it. So if you have a piece of string and you attach it to a board with 2 thumbtacks and you pull it tight and you trace it around, you'll actually be able to make an ellipse using that kind of MacGyver style. Anyway, let's do a couple of graphs that are centered at the origin. We'll learn how to translate them around the graph in a later video. Right, so the first one I've got is 9x squared plus 4y squared equals 36. Oh, we need to talk about how to find those foci. We'll do that in a second as well. And that's where the difference between a and b, actually, let me go back. That's where the difference between a squared and b squared is important. The foci are c units away from the center on the major axis, where c is the square root of a squared minus b squared, and c units away from center on the major axis. All right, so let's go back to the graph. First, we want to get it into the right form, and the right form has a 1 on the right-hand side of the equation, and so we can do that by dividing both sides by 36. 36 divided by 36 is 1. When we simplify the coefficients on the left, what we end up with is x squared over 4, because 9 goes into 36 4 times, plus y squared over 9 equals 1. A squared equals 9, so a is 3. B squared equals 4, so b is 2. And the center, there's not a value being subtracted from either x or y before being squared. So the center is at 0, 0. So in terms of graphing it, not worrying about the foci yet, but just graphing the ellipse, put a point at the center, 0, 0. The number being squared under x squared, that tells you how far to go left or right. So we're going to move 2 units to the left and right of that center. The number being squared under y squared, that tells you how far up or down to move from the center. And here that was 3 units. So 3, 3. Something like that. It's a little skeletonish, skullish. Anyway, the domain, if we look left to right, that goes from -2 to 2. The range, if we look from bottom to top, that goes from -3 to 3. Just read that from the graph. When it's not centered at the origin, though, those values of a and b are not going to necessarily show up in the domain and range. For the foci, c equals the square root of a squared minus b squared. So in this problem, that's going to be the square root of 9 minus 4, or the square root of 5. Now, the square root of 5 is about 2.2. So if we zoom in on the graph, the foci are going to be 2.2 above and below the center, like that. Right. Got one more for us in this video, and first thing we want to do is make sure that we get the x squared and y squared together on the same side. So if I add the 4y squared over to the left, we've got x squared plus 4y squared equals 16. Whenever you have an x squared and a y squared being added together on the same side, and their coefficients are different, you've got an ellipse. If the coefficients are the same, you've got a circle. Divide through by 16 to get it into standard form. We've got x squared over 16 plus y squared over 4 equals 1. A squared is 16, so that means that a is 4. B squared is 4, so that means that b is 2. So center at the origin, underneath x squared tells us to move 4 to the left and right. Underneath y squared, that tells us to move 2 above and below. Something like that. Now this time the major axis is horizontal, right? In the first problem that we looked at, the larger denominator was under y, so the major axis was the vertical one. This time it's horizontal, and that means that the foci are going to be on the horizontal axis instead. C equals the square root of a squared minus b squared. C equals the square root of 16 minus 4, which is the square root of 12. And if we simplify that, that's about 3.4. Let me just show you that. Square root of 12, 3.46, maybe 3.5 would be better. We could simplify the square root of 12, by the way. That's the same as 2 square root of 3. We see the same result there. So 3.46, if we're rounding to the nearest tenth, that's 3.5. So C is approximately 3.5. And so if we zoom in, the foci are going to be 3.5 to the right and the left. Pretty far from the center, relatively speaking. All right, what we're going to see is that that value of C actually can help us to figure out how close is this to a circle versus an oval. The more stretched out it is, we'll be able to tell from C. The more circular it is, we can tell that from C being compared to A. The closer C and A are together, the closer we are to a circle. Right. No, I'm sorry. Scratch that. We'll talk about that when we get to eccentricity in a later video.